Moles and Avogadro's number. A mole is a quantity that contains 6.022 times 10 to the 23 items, and usually atoms, molecules, or ions. For example, uh, dozen. What does dozen mean? It means 12 items. That items could be 12 dozen apples, means 12 apples, dozen bananas, 12 bananas. So when you see this word dozen, what do you think? You think about 12. You think about quantity is 12. Or if we say a case of soda means how many cans? Is 24 cans. Similarly, when we use the word mole means what? This just simply means these many items. The only difference is that a mole is much larger. So here, now this number 6.022 times 10 to the 23rd, that number is also known as Avogadro's number, after the Italian scientist Avogadro, who first proposed the concept of a mole in the 19th century. Mostly mole is abbreviated as MOL. We mostly write on MOL instead of writing MOLE. Now, this number can be used to convert moles to molecules or atoms or vice versa. For example, 1 mole of carbon atom means how many carbon atoms? 6.02 times 10 to the 23 carbon atoms. If we say 1 mole of water molecules, remember water is not an atom, water is a molecule, equals to how many water molecules? Same, Avogadro's number of water molecules. So, all we have to do is to uh, instead of using mole, just use this number, because mole represents 6.022 times 10 to the 23 items. So let's practice some of the word problems. For example, let's look at the first question. How many molecules of carbon dioxide are in 2 moles of carbon dioxide? So you have 2 moles of carbon dioxide, you have to change it to molecules of carbon dioxide. So what's given to you in the question? Given is 2 moles of carbon dioxide is given to you. Write down that first. Draw a line, put 1. Then put the same unit down here was here. So here is mole, so put mole here and write down the same thing, moles of carbon dioxide. Why the same thing? So that you can cross them out. You can cross, and on the top write down what do you want to find out. You want to find out molecules of carbon dioxide. And what's the relation between moles and, so 1 mole of carbon dioxide equals to how many molecules of carbon dioxide? 6.022 times 10 to the 23rd. Now moles of carbon dioxide here cancels with this. What is left? Molecules. And what is 2 times 6.022? It is 12.044 times 10 to the 23rd. Or if I change it to the scientific notation, that will be 1.2044 times 10 to the 23rd molecules of carbon dioxide. That means to convert moles to molecules, you multiply by this Avogadro's number. Next question is, how many moles of carbon dioxide are in 3.011 times 10 to the 23rd molecules of carbon dioxide? So in this question, they gave you molecules, these many molecules of carbon dioxide. So the number that's given to you in the question, you write down that first, you draw a line, you put 1 here in the conversion factor, in the denominator, you write down the same thing that's here on the top so that you can cancel them out, and here you write down what you want to find out. You want to find out moles of carbon dioxide. And we know the relation is 1 mole of carbon dioxide equals to 6.022 times 10 to the 23rd molecules of carbon dioxide. Molecules cancel. 10 to the 23rd, 10 to the 23rd cancel. 3.011, 6.022, and here will be 2 because 3.011 times 2 is this. So what is the answer? Half moles of carbon dioxide, which is 0.5 moles of carbon dioxide. Um, I'm going to explain you question number 3 also, just to tell you the difference between second and third. For example, in this one, how many atoms of carbon are in 2 moles of carbon dioxide? This is a little bit different. Now you know that you have to start writing with, you have to start with this 2 moles of carbon dioxide because that number is given to you in the question. Then here in the conversion factor, you're going to have moles of carbon dioxide here. Now you can go from moles of carbon dioxide to molecules of carbon dioxide. There is no way you can go from moles of carbon dioxide to atoms of carbon. No, because carbon dioxide and carbon, these are two different substances. And we know 1 mole of carbon dioxide equals to 6.022 times 10 to the 23rd molecule. Mole cancels with mole. Now, but we do not have to find out how many molecules of carbon dioxide are there. We have to find out how many atoms of carbon. So we're going to use one more conversion factor, and we know here in the denominator we have to write down the same thing that's here so that we can cancel them out. Now, here's the thing, one molecule of carbon dioxide. One, if you look at carbon dioxide, we say one molecule of carbon dioxide is made up of one atom of carbon and two atoms of oxygen. So that means here in the conversion factor we can say one molecule of carbon dioxide has how many atoms? One atom of carbon. So now when we cancel molecules with molecules, what is left? Carbon. So this question tells you that sometimes you're going to have more than one conversion factor to find out what you are looking for. So in this particular question, what will be the answer? So you have 2 times this number times 1. So basically 2 times Avogadro's, which will be 12.044 times 10 to the 23rd, or in the scientific notation 1.2044 times 10 to the 24th atoms of carbon.
Made with Doodlecast Pro.